Alright, so today we're going to talk about multiplying our radical expressions now. So yesterday we talked about adding and subtracting them. Now we're going to talk about what happens when we multiply them. Now we got a little taste of this when we simplified our radical expressions, but now we're going to kind of go into it a little bit more in detail. So let's say we had an expression such as 3 radical 2 times 2 radical 6. Okay, so when we have an expression like this, when we are multiplying them together, again, this kind of follows the same multiplication rules as when we had variables. What we're going to do is we're going to take the numbers or the coefficients and we're going to group those together and multiply them. So this is going to become 3 times 2. And then we're also going to group our radicals together, and we're going to multiply them. So unlike what we did with adding and subtracting, where as long as they were the same, we were able to add the coefficients, here it doesn't matter. They don't have to be the same. We can multiply these two, no problem. We'll just group them together, radical 2 times radical 6. And then we're going to just multiply those together. So we're going to do this in groups. So we're going to do 3 times 2 first, which is 6. And then we're going to do radical 2 times radical 6. So we are able to just multiply the radicands. 6 times 2 gives us radical 12. Now the only other problem with when we do something like this, we have to make sure that my radical is simplified. We always check to see if the radical is simplified. Okay, just like we did yesterday, when we had to add them, we had to simplify first. Just like we did the previous day, where we had to always look to simplify, we have to see if this radical can be simplified. So I'm going to take the square root of 12. I'm going to write out all of my perfect squares. I'm going to work with from 12 on, and I'm going to say which one of these is the greatest perfect square of 12. 9 is not, but 4 is. So the square root of 12, I'm going to bring my 6 down, can be rewritten as the square root of 4 times 3. Because again, 4 times 3 is 12, and 4 is the greatest perfect square of 12. So this now, again, I bring the 6 down. The 4, or the radical 4 times 3 becomes radical 4 times radical 3. And the square root of 4, we know, is just 2. So I'm now going to have 6 times 2 radical 3. And out front, I just have 6 times 2, which becomes 12 radical 3. So that would be my final answer. So as we see here, when we multiply, we group the coefficients together and multiply them. We group the radicals together and multiply them. Unlike addition, they do not have to be the same. Multiply the coefficients, multiply the radicands, and then simplify. So let's do another one. Let's say instead of having it just like this, what happens if we have one where we're both multiplying and adding? Something like 3 radical 5 times 2 radical 5 plus 5 radical 3. So here, not only do we have to look to try to add, we also have to multiply, because we're now taking this and multiplying it through to this entire addition problem. So when we're left with something like this, what we want to do is we want to distribute. I want to take this 3 radical 5 and distribute it through to both terms on the inside. So when I do that, I have to do this concept twice. So I'm going to do 3 radical 5 times 2 radical 5 first. Well, just like we did over here, we're going to group the coefficients together. So it's 3 times 2. and we're going to group our radicals together. And that's going to be square root of 5 times square root of 5. So 3 times 2 becomes 6. And now square root of 5 times the square root of 5 is technically the square root of 25. But we know that the square root of 25 is just 5. So really it's 6 times 5, but we know that 6 times 5 is 30. So that's going to be this first half of this. Well, now I have to go to the second half. Now I have to do the 3 radical 5 times the 5 radical 3. So just like we did with the previous one, I'm going to group together my coefficients, 3 times 5, and then I also group together the radical 5 and the radical 3. So here I multiply the 3 times 5, which gives me 15. I multiply the radical 5 times the radical 3, which gives me radical 15. But again, I need to make sure that radical 15 is completely simplified. So I go and I say, all right, if I go over to my perfect squares, I look, here's 15, so I'm using everything above 15. 15 divided by 9 doesn't work. 15 divided by 4 doesn't work. So that means that this is completely simplified. So we don't have to simplify this. We're good. We did our first part. We did our second part. Now what I want to do is I want to take these and I want to combine them using the sign. So again, we kind of have to bring that sign down with us. So my answer here is going to be 30 plus 15 radical 15. That is going to be my final answer. So here I've put 4 more problems up on the board here. So let's see if you guys can do these on your own. So again, take the time, pause the video, and try to simplify these multiplication of your radicals. So here are the answers that we should be getting. So again, for the first one, multiply the coefficients. 2 times 7, you get 14. Multiply the radicals. Radical 6 times radical 3, you should get radical 18. But radical 18 can be simplified. Radical 18 gets split up into 9 times 2, which that is radical 9 times radical 2. And radical 9 becomes 3. And 14 times 3 brings us to 42. So that's how we get our 42 radical 2 there. Same thing over here. 9 times 11 gives us the 99. Radical 5 times radical 15. 15 times 5 gives us 75. So I have 99 radical 75, but radical 75 can be split up. 75 can be split up into 25 times 3. So we have 99 times radical 25 times 3. This can be written as 25, or radical 25 times radical 3, which then the radical 25 is 5. And 99 times 5 gives us 495. Down here, we need to distribute. So 3 times 4 gives us 12. 2 times 3 gives us 6. This can't be simplified, so this stays exactly as is. 3 times 6 is 12. Radical 2 times radical 2 becomes radical 4. But radical 4 is just 2, so 12 times 2. Oh, sorry, 18. My mistake, 18. See? Yeah. Got to check yourself. 18 times 2 gives us 36. And then same thing here. We use a different color for this one. Distribute. 5 times 3 is 15. Radical 3 times radical 2 is radical 6. can't be simplified, stays as is. 5 radical 3 times radical 3, that's going to give us 5 radical 9, because radical 3 times radical 3, radical 9, but the square root of 9 is 3, and 5 times 3 gives us 15. So hopefully this made sense to you as you were doing this. If not, please rewind and go through this concept again with what I was doing before. So let's try a little bit of a more difficult problem here. Let's say we had a rectangle, okay? And let's say our rectangle here had a length that was square root of 5 plus 4 square root of 3, and a width of 5 square root of 2 minus the square root of 3. And let's say we wanted to find the area of the rectangle in simplest form. Well, first of all, we need to know that the area of a rectangle is equal to the length times the width. And again, we should know this. Doesn't matter which side I make my length or my width here. So we'll call the length this side here, and we'll call the width that side. So we know what my length and my width are. So that means that I'm just going to replace the length with 5 radical 2 minus radical 3. And I'm going to replace the width with radical 5 plus 4 radical 3. So here I have two binomials that we want to multiply together. Well, if we think back to what we were doing in chapter 8 and 9, chapter 8, when we were working with our multiplying, this is a double distribution problem. I take my first term and I'm going to distribute it through to both terms. Then I'm going to take my second term and distribute it through to both terms. So when I do this, my first term here, and actually, let's do this, first term here, when I do that, 5 radical 2 times radical 5, that's going to give me, if I look at the coefficients, 5 times 1 is 5. Radicals are radical 2 times radical 5, that's going to give me radical 10. Then I'm going to do this part here, because of the double distribution. 5 times 4 is a positive 20. Radical 2 times radical 3, that's a radical 6. Then I do the next step, start the double distribution on the second term. Now remember, this is a minus radical 3 times radical 5, so that's going to be a minus radical 15. And then I'm going to do the last one, minus radical 3 times positive 4 radical 3. Negative 1 times 4 gives me negative 4. Radical 3 times radical 3 gives me radical 9. So now, once I've gotten all of this, now I have to go through this and make sure that I can't simplify anything. Or if I can simplify something, I have to actually simplify it. So starting with the 5 radical 10, again, we're going to have our perfect squares over here. We don't have to go too far here because our biggest number is 15. So we say, okay, 10. 10 falls right here. Does it have a greatest perfect square factor? In this case, it does not. So we're good. We can just leave this as 5 radical 10. I do the same thing with 6. 6 falls here. It also does not have a perfect square factor, so I leave it as 20 radical 6. I do the same thing with 15 and recognize it also doesn't, so minus 15. But now here, the square root of 9, that's a perfect square. So this is actually 4 times 3, because the square root of 9 is 3. And when I do that, I get 4 times 3, which gives me 12. So now I just have to look here and say, is there anything that I can add together? Are any of my radicals the same? Well, the answer to that is no. I have a radical 10, a radical 6, and a radical 15, so I can't combine any of them. We just showed that we can't simplify any of those either, so that would be my final answer. So whenever we're working with this, we just have to make sure that when we multiply them, we always check, can any of these be simplified? If they can, we have to simplify them, and then can I combine them after I simplify? Meaning, do any of my radicals have the same radicand? If so, add the coefficients together.